Right, welcome back. Here is the solution. Number one, you want the y-intercept. For y-intercept, you put x equal to 0. Therefore, c is equal to -3. Or you can write it as an ordered pair, 0, -3. Number two, for x-intercepts, put y equal to 0. So you will have x cubed minus x squared minus 5x minus 3 is equal to 0. You're going to test x minus 1, x plus 1, x minus 2, etc. And when you test all of these, you will find that x minus 1 is a factor. You'll find this one is a factor. When you try this, or let's try it for you. If you try f of 1, if you're trying this one, it will be f of 1 is equal to 1 cubed minus 1 squared minus 5 into 1 minus 3, which gives you minus 3 minus 5, that's minus 8 minus 9 plus 1, gives you minus 1. So this is not a factor. Then you try this one. If you're trying this one, obviously you will have to make it equal to 0, so x is equal to minus 1. When you try f of minus 1, you got minus 1 cubed minus 1 squared. It's very important to use these brackets like this. Minus 5 into minus 1, minus 3, and that gives you 0, right? That gives you, because that's minus 1 and that's plus 1. That will give you minus 1, minus 1 will give you minus 2, minus 5 and plus 5, and finally it will be 0. So x plus 1 is a factor. So you will say, well, x cubed minus x squared minus 5x minus 3 is equal to x plus 1 into x squared, because x times x will give you x squared. This is minus 3, this is 1, therefore this will be minus 3. In the middle you'll write bx. Then you're going to solve for b, right? So if you're solving for b, you'll multiply like this. You'll say these two and those two. So if you take that, it will be minus 3x plus bx is equal to minus 5x. Then you solve x into minus 3 plus b is equal to minus 5x. Minus 3 plus b is equal to minus 5. b is equal to minus 5 plus 3. b is equal to minus 2. So we have found b. b is minus 2. Now, so the final answer will be x plus 1 into x squared minus 2x minus 3 is equal to 0. And then you're going to factorize that. So it will be x plus 1 into, that will give you x minus 3 into x plus 1. x minus 3 into x plus 1. When you're going to make each bracket equal to 0, x will equal to minus 1, or x will equal to 3, or x is equal to minus 1. So in this example, you got two x-intercepts which are the same. You got -1 and -1 two times. Alright, so we finished 1, we finished 2. Now we're going to move over and find the derivative, which is number 3. So number 3, let's find the derivative. So I'm going to say y prime is equal to 3x squared minus 2x minus 5. Find the derivative. 3x squared minus 2x minus 5. Make the derivative equal to 0. 3x squared minus 2x minus 5 is equal to 0. Factorize. So if you factorize this, you will have 3x minus 5 into x plus 1. Let's test. 3x squared minus 5x plus 3x will give you minus 2x minus 5, correct. Then if you 3x minus 5 is equal to 0 or x plus 1 is equal to 0, this will give you the answer. X is equal to 5 over 3 and here you'll have x is equal to minus 1. Now you are looking for the stationary points. So for x equal to minus 1, y is equal to, now you substitute in original equation. So y is equal to minus 1 cubed minus into minus 1 squared minus 5 into minus 1 minus 3, and that will give you the final answer. Let's see. Minus 1 cubed minus into minus 1 squared minus 5 into minus 1 minus 3. That will give you negative 1 and that will give you negative 1, so that's negative 2, negative 5 and positive 5 you'll get 0. So the ordered pair for this one is negative 1, 0. Now for x equal to 5 over 3, y is equal to 5 over 3 cubed minus into 5 over 3 squared minus 5 into 5 over 3 minus 3. Now let's get the calculator for that one. And when you take the calculator and put that into the calculator, you will get minus 9,5. Minus 9,5. We round off to one decimal place. So this one, so this ordered pair will become x is 5 over 3. Well, 5 over 3 is really 1 and 2/3. And this is negative 9,5. Well, there's another way, another secret. If this is positive, we know the graph goes like that. So the number on the left, if you take the 2x values, this value here and this value here, the one on the left will be a max, the one on the right will be a minimum. If this is positive, it goes like that. If x is negative, then the graph goes like that. You see? If x is negative, the graph goes like that. If x is, if the number in front of x cubed is negative, if the number in front of x cubed is positive, the graph goes like that. So we already know that this one, you can try the number line method I showed you, or you can try this method. So clearly, out of these two, this one is on the left. So this one will be going that way, and this one, which is on the right, will be going this way. So we are now ready to draw the graph. Right, so let's see. I'm going to draw the graph on this here. So let's just get ready to draw the graph. Okay, so what I'm going to do, I'm going to write, it doesn't matter, you got this on a page somewhere in front of you. Right, let us see. So let's start with this. The y-intercept is negative 3. The y-intercept is negative 3, so let's say that's negative 1, negative 2, negative 3. The y-intercept is negative 3. Right, we've done that. Then the x-intercepts. The x-intercepts are negative 1 and 3. Just two active. Negative 1, 3 and negative 1. So negative 1 appears 2 times. So there's negative 1, negative 2, negative 3. And say 1, 2, 3. So it's negative 1 first time, then negative 1 again, and then it is 3. We're finished with that. Now, at negative 1, 0, at negative 1, 0, watch carefully, at negative 1, 0, at negative 1, 0, the graph goes this way. At 1 and 2/3 minus 9, 5, the graph goes this way. So we haven't plotted this. We're going to plot this now. 1 and 2/3. So 1 and 2/3 is somewhere here. And let's say that's negative 8. And let's say that's negative 9. Now you want negative 9, 5. So negative 9, 5 will be in the middle here. And here the graph goes this way. Right. Now all left to join. From there, you know the graph must go down through minus 3 and join there. So it'll come down through minus 3 and join there. Then from here, it'll go up through 3 there. Let's see if it's right or if there is a problem.